Let's look at LeChatelier's principle from a qualitative and quantitative understanding to examine how systems reestablish equilibrium after they've been stressed. So LeChatelier's principle states that if a chemical system is at equilibrium experiences a change, then the equilibrium will shift to partially counteract the imposed change. That is, the new equilibrium will form in a fashion which tries to undo the change that you have imposed. We can look at this in the context of adding or removing reagents. And so let's take this example of nitrogen and hydrogen form ammonia. Imagine you found a reaction mixture which was at equilibrium already, and then you decided to add more hydrogen gas to that mixture. What will happen as the reaction shifts to the new equilibrium? That is, will it shift in such a way that the reaction moves to the right or to the left? Will this lead to a concentration decrease of nitrogen, a concentration decrease of ammonia, or when equilibrium is reached, all the concentrations will be identical to what it is before? So think about this for a moment, pause the video, see if you can answer it, then the answer will magically appear. So here's the answer, is that, of course, if you add something to the reactant side, the equilibrium is going to shift to try to undo that change. And the way it can do that is by moving molecules from the reactant side to the product side. And so you'll see a decrease in the concentration of N2. The system's going to compensate by reducing the stress. You added H2, the reaction will reduce H2. So if you add reactants, the result is always going to be a reaction shift towards the products. The same is true as if you remove products, the reaction will shift to compensate and form more products. On the other hand, if you add products, then the reaction will shift and will look to generate more reactants. The same will happen if you remove reactants. Look at another question now, which is what happens if you increase the pressure of the system by changing the volume. So now you find the same system at equilibrium, it's at an atmosphere, then you decide to compress the system and the pressure is increased to 2 atmospheres. What happens as the reaction goes to the new equilibrium? Does it move towards the products? Does it move towards the reactants? Or does it move towards the products because they have a lower free energy? So we have to decide on the reason and the direction here. You can pause it, think about it, and then the answer will appear. So here it's going to move towards the products because they have fewer molecules. You increase the pressure. Reaction's going to try to reduce that change, that stress you put on it. The only way to do it is to change the number of molecules, and there are fewer molecules on the product side. So as the equilibrium shifts to the product side, there'll be fewer molecules in the mixture, and this will effectively reduce the pressure. So let's deal with this from a quantitative perspective a second, because when we talk about LeChatelier's principle, it seems to be often that people confuse this to think that somehow the reaction is deciding what to do and that it's working against you to counteract all the things that you've done. The only thing that's happening is the system's going back to equilibrium. The equilibrium is the lowest free energy state. It was at some low free energy state, and then you did something and you moved it away from that state. And then the question is, which way is the new equilibrium? And that's always the same question, which is Q versus K. And so if we imagine this situation, at equilibrium, I happen to find these concentrations. If I know those concentrations, I know what the equilibrium constant is. So if I put them into the mass action expression, then with the equilibrium concentrations, the mass action expression is equal to the equilibrium value. And in this case, we're using concentration, so it'll be Kc. I plug all those numbers in, and I find that the equilibrium for this reaction, at whatever temperature this happens to be, is 0.06. Now, what's going to happen if all of a sudden I increase the nitrogen concentration from a little less than 1 molar all the way to 3 molar? The system's not going to be at equilibrium anymore, and which way will it shift to get back? Well, now we have new concentrations. These are the concentrations not at equilibrium. This is some instantaneous moment. And so now the mass action expression is equal to Q, the reaction quotient. This is the value not at equilibrium. So if I plug those all in, I now get something as 0.0185. And if I compare that now to K, I can see that Q is now less than K. What's happened is it's products divided by reactants. If I add reactants, now I'm dividing by a larger number. That's going to make Q smaller than K, and therefore the reaction needs to move towards the product side to go back to equilibrium. Conversely, if I'd added products, I would have made Q larger than K because I'm putting something on top of the mass action expression. And so you can see that for all of these adding reactants or removing reactants or adding products or removing products, it's the same question as Q versus K, and we can just remember it in terms of LeChatelier's principle. One very key lesson to learn here is that in order to change the equilibrium, the component that you're adding, the chemical compound you're adding, needs to appear in the mass action relationship. So pure solids and pure liquids whose activities are 1, they don't show up in the equilibrium constant. And so adding more of them to a reaction mixture doesn't do anything because it doesn't have an effect on the free energy. So as long as you have some solid, it doesn't matter how much of it there is. And you probably remember that from solubility. If you have a saturated solution, it has some solid, has a concentration of ions in the solution, you can add more solid, but it doesn't make any difference. You still have the same concentrations in the solution. That's the idea of saturation.